Alright, in problem number 2, we're asked to find how many sets of 2 or more consecutive positive integers have a sum of 15. Alright, well, let's think about this. We want to find 2 or more. So the first case we could look at is when we have 2 consecutive positive integers. Okay, so case 1 might be 2 integers that sum to 15. Okay? And then we could break this down into, different cases. 2 integers, 3 integers, 4 integers, until we can't find any more. And then we just count them up. So, why don't we go ahead and do that? So for the first case where you have 2 integers, you might think of, you might actually just think of the 2 numbers. I guess that one isn't too terribly hard. But another way to look at it too is that these numbers are fairly close together. They're only off by 1 because they're consecutive. And so if you were to find the midpoint of those 2 numbers, it's sort of like the average. You would, sum up the 2 numbers, they should equal 15, and divided by 2, that would be the midpoint. So if we take 15, whoops, I better put a 1 there, and divide it by 2, we get what? We get 7.5, right? 7.5. So 7.5 is the midpoint between what 2 numbers? Well, if we've got only 2 integers, then 7 plus 8, 7.5 would be right between the 2 of them. And does 7 plus 8 work? 7 plus 8 obviously is 15. So there's one case, alright? In the case of 2 integers. Now there's actually a couple different ways you could look at this. Another way is just to say, okay, the first number I'm going to call n, alright? And I want to find another number that's consecutive, n plus 1, alright? So we're adding 2 numbers, n and n plus 1, and we want that to equal 15. So if I add those 2 up, I'll get 2n plus 1 equals 15, or 2n equals, I can subtract 1 from both sides, 2n is 14, and so n is equal to 7. Okay? And that just gives us the same answer. So the first number is 7, and the second number is n plus 1, which is 8. So the 2 numbers are 7 and 8, which gives us basically this, gives us exactly the same answer here. So our first case is 7 and 8. Alright, so this is just 2 different ways to approach it. You can either look at it in terms of the middle number, which would be the average, since these numbers are evenly spaced. So, the number that's right in between is 7.5. Now that's not an integer, but when we only have 2 numbers, we wouldn't expect an integer, right? Because the middle point between 7 and 8 is going to be 7.5, right? So let's look at another case. Okay, let's look at case 2. Case 2, let's look at 3 integers. Okay. And so we can do the same thing. If we've got 3 integers, then the middle number has to be the average. So we could take 3 into 15 and we get 5. And what group of consecutive numbers gives you 5 as the middle? Well, we can just put 5 and go 1 on either side. So 1 more would be 6, 1 less would be 4. And does that work? Well, 4 plus 5 is 9, plus 6 is equal to 15. So yes, it works. So that's good. And again, the other way you could do it, you could say that n is the first number, and n plus 1 would be the second number, and n plus 2 would be the third number. That should equal 15. So let's see, we have 3 n's plus 4, right? Whoops, wait a minute, that shouldn't be 3. That should be, I think I said 2, but but I didn't write 2. So this should be a 2. Alright, so we have 3n plus, gosh, let's see. We have 3n plus 3 equals 15, which gives us 3n equals 12. Okay, just subtracting 3 from both sides. And then we have n equals 4, right? So our first number is 4, so the second number will be 5, and then 6. So I'm just showing you two different ways you can approach it. So you just decide whether which way you prefer. Alright, so let's keep going. Let's go to case 3. Alright, 4 integers. Okay, so let's take 4 into 15, and what do we get? Well, let's see. Looks like 3 would be 12, and then we'd have 3 left over, so it's 3 and, 3/4. That's a little different from what we've seen before. If we have 4 integers, now obviously the middle point between those integers is going to be right between the middle two, right? But here we have 3 3/4. So it's not right in the middle of two integers. So that would make you suspicious. Now I could say, okay, let's see, one of the numbers is 3, and let's say we want to go a little bigger, we want to go a little smaller than 3. Our middle point was here, so maybe if we add 5, well, if you look at this, oops, that should be a plus. If you look at this, let's see, we have 5 plus 4 is 9 plus, that's 14. That's not 15. And if I go the other way, if I say 1 plus 2 plus 3 plus 4, that doesn't do it either. So it looks like we can't get 4 consecutive positive integers that sum to 15. So I had to forget about that case. And we could also look at it this other way. So n plus 2 plus n plus, whoops, hang on. I'm getting ahead of myself. This shouldn't be n plus 2. I gotta start with n plus 1, right? Consecutive integers. So n plus 1, n plus 2, and n plus 3. That gives us 1, 2, 3, 4 consecutive positive integers equals 15. So we end up with 4n plus 1 plus 2 plus 3, which is 6, equals 15, right? And if we subtract 6 from both sides, we get 4, n equals 9, and you can see that there's no integer that would satisfy this equation. If we divide both sides by 4, you can see that n is not an integer in this case, right? So n would be 9/4, and there's no way to make that an integer. So there is no case 3. Alright, there's no 4 consecutive positive integers. So let's go on to case 4. Now you may have seen the answer when we looked at 2 plus 3 plus 4 plus 5, because that was 14. If we just add one more, we'd get 15, right? So if we divide 15 by 5, we get 3. So we want 5 consecutive, I didn't write that out, did I? 5 integers. Okay, that's case 4. 3 plus 4 plus 2 plus 5 plus 1. So this is the series of numbers where 3 is in the middle. And does it work? It better, right? So we have 6, 10, 15. Yay! Alright, so we have another one. And again, you could do it algebraically as well. You would end up with, I should say, 5n plus, okay, I want to add 4, but plus 10. Alright, I'm kind of taking a shortcut here. But you could see then that 5n equals 5, and so n equals 1. So 1 would be the first integer. Okay? So we have 1, 2, 3 ways of getting 15 with 2 or more consecutive positive integers. Can we find any more? Well, to get any more, we would have to shift this series back a little bit, right? Because we got more numbers, so the smallest one would have to be smaller, which would end up being negative. And so, and we're not asked to find we're asked to find the consecutive positive integers. So this is the extent of what we can do with the positive integers to find a sum of 15. Now you could also look at it as, if you tried to find 6, then you'd end up with n plus 1 plus n plus 2 plus n plus 3 plus n plus 4 plus n plus 5 equals 15. And you can see we'd have 6 n's, and then we have 1 plus 2 plus 3 plus 4 plus 5, right? 1, 2, 3, 4, 5, 6. Yeah, so what is that? We have 9, that's 15, right? So 6n plus 15 equals 15. Well, 6n would have to be 0, and that would mean n would have to be 0. So I guess that's an issue. Is 0 a positive integer? And the answer there is that no, 0 is not positive or negative. Okay, it's sort of in no man's land there. It's not positive, it's not negative. So even though we could write 0 plus 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. That looks like 6 consecutive integers. It is 6 consecutive integers, but 0 is not positive. It's not negative either, but it's not positive, so that one does not count. Alright, so our answer is that we have 3. We have a total of 3 sets of consecutive positive integers that will sum to 15.